Let me know if you're not able to. Oh, I think I'm not sharing my screen, right? Okay, I'm sharing my screen now. So let me know if you're not able to see my PowerPoint slides. All right. If you look at the example here that you see on the screen here, we are having 3 elements. Okay, so element 1 is connecting point 1 and point 2. Element 2 connecting point 1 and point 3. Element 1 is connecting point 1 and point 4. As you can see here, this is an example where it's combined chapter 2 with chapter 3, where you're seeing spring structure and bar truss structure. Okay, so this will be the one that might be come out in your test, this kind of structure, or might come out in your final exam. All right. So as you can see here, first look at the diagram, identify how many elements you have, what are the node, what are the points that you need to focus on. In this, you have 4 points. Okay, and if you look at the general axis here, you are given the general axis x and y, and you're also given the general axis of x prime 1, x prime 2, and x prime 4. Right? Now, before we move forward, I have one question to ask all of you. Okay, there's one external force here, 25xy. So you are having, okay, the first question, how many point or node you have? Look at the diagram. How many points or node you have in this system? Okay. Then after that, answer this question. How many displacement point or displacement you have, or degree of freedom you have? What is the total displacement that you have if you want to calculate the whole thing? How many U and V or W that you need to calculate by just looking at this diagram? Okay, solve this one first, then answer the second one. Okay, I give you some maybe 10 more seconds to look at the diagram. First question, how many nodes are there? How many points that you need to focus? Second, after you get the point, answer this question. How many displacement that you need to solve? Or at least in your answer, you'll be seeing how many U, V, or even W in your solution. Okay, let me test the class. Sue, are you there?
Yes.
Okay, Sue, how many points you have in the system? Like what you see on the screen here. How many points?
I think it's
How many points? How many points?
3.
3.
1, 4.
3 or 4? You understand what is point? What is node?
I think it's 4.
4. What are the 4? So, okay. Ashma, what do you think? How many points we have on the diagram here? Ashma, are you there?
Yes, sir.
Yeah, how many points we have in our system?
4.
4, okay. So how do you know 4? Okay. Element 1, you have point 1 and point 2. Element 2, you have point 1 and point 3. Element 3, you have 1 and 4. So total, you have how many points? You have 0.1, 0.2, 0.3, 0.4. Total, you have 4 points to solve. Okay, answer is 4 points. Then the next question I'm going to ask, how many displacement you have in this system? Okay. Chia, you want to Chia Wing Fong, you want to try to answer how many total displacement you have in this system?
I think 3.
Three. You have 3 elements. Okay, 3 elements. 3 elements, 4 displacement. That's your answer. You understand what is displacement or not? Displacement means movement. Total movement that you have inside this system. And this movement is based on the point that you have in the system. Okay, never mind. I try to ask Brian. Are you there, Brian?
Yes, sir.
Yeah. How many total displacement you have in the system that you need to calculate? What is the total displacement? Total number of displacement.
1.
Your answer is 1.
At point 1 is a displacement.
Okay. Let me try. What about Sue? What do you think? How many displacement you have?
4.
Okay, your answer is 4. We have 3, 4. Okay. All right. Now, all of you know we have total of 4 points, right? All
Sir.
of you agree, right? Go ahead. You want to try to answer?
Each element with its own displacement.
Yeah, I talk about the total displacement that you need to calculate. So for example, okay, try do it slowly. Element 1 will give you displacement at point 1 and point 2. So each displacement, you need to displace x and y direction, correct? So you have u and v here. Or in this case, we don't have z, so you only have 2. So you have u1, v1. You look at point 2. Point 2 also, you need to refer to 2 axes here. So you have u2, v2. For element 1, you have 4 displacement for element 1. Okay. Why? You can say that like this because when you calculate the small f equal to kd, the displacement here referring to element because you're using f. Okay. So for element 1, you have 4 displacement. I'm going to repeat until all of you understand. You look at element 2. Element 2. Element 2 connecting point 1 and point 3. So element 2, point 1 also referring to 2 axes, x and y. So point 1 give you u1, v1. Point 3 give you u3, v3. So for element 2, you have 4 displacement. I'll repeat the third one. Oops. Okay, I already explained the 1, 2. Okay. So u, v, U, V, U, V, U, V. 1, 1, 2, 2, 1, 1, 3, 3. I'm going to repeat the third one. Element 1, element 2, element 3, point 1, point 4. Again, you're referring to axis X and Y. U1, V1, U2, U4, V4. So for element 1, you have 4 unknown, 1, 2, 3, 4. Or I can label this one as A, B, C, D. Element 2, you have U1, U1, U3, V3. So U1, V1, you have A, B. 3 is a different one. You have D and E. Element 3, you have U1, V1, you have A, B. Element 4, you have F and G. So how many unknown you need to solve?
How
many unknown? Anyone? How many unknown you need to solve?
So 12?
You calculate 12. Is there 12 there? 1, 2, 3, 4, 5, 6, 7, 8.
So wait a moment. So like for element 1.
Yeah. How many displacement, unknown displacement? Anyone just now? I heard something. How many unknown displacement you need to solve? I already draw up all the unknown here. How many unknown you need to solve?
6.
Oh, you can count, right?
So for element 1, you have U1, V1. And then U2, V2. And then U2 and V2 and U2 will be, that's fixed, right? The only one that has displacement is U1 and V1, right?
Okay, so what does it mean if I write A, B here, or U1, V1, and U1, V1 here, or U1, V1 here? Is there same? Are they same? Are they same?
Yeah.
Are they same? Are they same?
Yes, same. This one, okay, no, it's like this one, AB, this freedom, free to move.
Yeah, so if they are same, are you count as 6? Or you only count at 2? You're already looking at A, B value, or you're looking at AB, AB, AB. You need to calculate 6 times. Meaning, are you going to calculate A 3 times, B 3 times?
You calculate once, like AB
you only
is
calculate
a point.
A and B, right?
Yeah.
Because they are the same. You need to calculate U1, V1. Then you can do the same for U1, V1 here, U1, V1 here, correct?
Yes.
So how many displacement you have inside this
3.
system? How many alphabet you count here?
So wait.
How many different? Yeah.
I'm a little bit getting confused. Like point AB. So you calculate, you count as that one, right? Like U1, V1.
U1 consider one.
One point.
Displacement. Okay, U1 consider one displacement. V1 consider another one displacement. So this one is 2 displacement. Then if you count V2, V2 is one more displacement. V2 another displacement. So how many displacement you have here? Like what you see on the screen here. How many unknown? How many alphabet that you need to calculate?
The one?
Eight.
It's confusing.
You're confusing?
Because you said U1, V1 at point for element 1.
Okay. I'm going to repeat until all of you get it. Right. So I start from the very basic one. All of you agree that we have 3 elements, right? This one, all of you able to see, right?
Yes.
All of you have 3 elements. So 1, 2, 3. Okay. Now, I draw the first element. Element 1. You have 2 points, right?
Yes.
Okay, I write. Total, you have 4 points. 4 nodes.
On element 1.
No. All the system, you have 4 points, correct?
Okay.
Inside,
Okay.
you have point 1, point 2, point 3, point 4. Agree?
Yes.
Okay.
Don't confuse with all these name. Element means how many subject you have, how many bar you have or spring you have. So you have 3 elements there. Then you have 4 points. 1, 2, 3, 4. Okay. Okay. Now back to. I try to go slowly. Try to understand because this is important. If you're not able, then you ask until you understand what we are meaning. Because if not, then you will get lost in the mathematics later on. Element 1 connecting point 1 and point 2. Each one will have 2 displacement. Each n will give you 2 displacement. Because you are referring to x and y direction. Okay, x and y direction here. So each one will give you u1, v1. Correct? Now point 1 can move to the x direction or y direction, right? Agree? Then point 2 also give you another 2 movement. Sorry. u2, v2. So if you calculate point 1 only, element 1 only, then you have 4 movement, 4 displacement for one element. You have 1, u1, v1. You count as 1 movement, 2 movement, 3 movement, 4 movement. Get it? This is how we count the displacement for element 1. Oh, if you're able to understand, there are 4 displacement for element 1. Do you guys agree? Okay. Now I repeat for element 2. Okay, maybe I do it here. Element 2. Connecting point 1 and point 3. Same. You're referring to x and y direction. So for point 2, you have u1. Point 1 can move to x and y direction. u1, v1. v1 is y direction according to the axis. Point 3 also same. You have u3, v3. So for element 2, you need to solve 4 displacement here. Agree? Are you able to see? Agree? So you agree?
Yes.
Okay. I'll repeat this, the third one. I use the red color also. Oh, sorry. The fourth one. Point 1 and point 4. So element 3 also have 2 points that you need to refer to x and y axis. So point 1 can move to the left and to the on top of that one. So U.1 for element 3 will give you U1, V1. 0.4 will give you U4 and V4. So element 3 also have 4 possible movement. Okay. Can you count the different displacement that you have? How many total displacement that you have? Means how many total unknown that you need to solve in the diagram? What is the total unknown number that you need to solve?
True.
Yes, sir.
Huh? Ashmal, are you able to answer?
8, sir.
Sorry?
8, 8.
8 ah.
8.
Okay, I start counting whether my mathematics is wrong or 1, 2, 3, 4. I go to element number 2. U1, U2 repeated, so I don't need to count. I continue to count. 5, 6. I go to element 3. U1, V1, I don't need to count because it repeated. 1 and 2 repeated already. I go to 0.4, 7, 8. Are you able to see why we have 8 displacement in the system?
Oh.
Try to link this number and this number. As long as you have 1 point, you need to refer to the axis. Each point will give you 2 displacement. You have 4. So 4 times 2, 8. The one that I draw on the right hand side is a more detailed one.
I think the confusing bit was the U1 and the V1.
Why do you mix up with all the point?
Yeah, for me, the way I was calculating is that, for example, element 1. I would,
You just okay. So you just imagine, for example, 0.1 is you. Okay, 0.1 is Brian. 0.2 is Ashmal. 0.3 is Sue. 0.4 is Chia. Why do you want to confuse yourself with all these points? Right? So for example, element 1, 0.1, you still Brian, right? 0.3
yes.
Element 2, 0.1 still Brian, right? Here also still Brian, right?
Yes.
Element 3, 0.1 here still Brian, right?
Yes,
Why you want to confuse yourself? Why do you want to like you are still inside this system. There are no 3 Brian. There only 1 Brian there. Brian have 2 hands, X and Y direction. So you're not going to split to 6 Brian or 3 Brian. They only have 1 Brian with 2 arms.
Oh, understand,
Okay. So don't make mistake in final exam or test. Okay, I hope I explained it very clearly. Any one of you still not clear why we have 8 displacement? Any one of you still not clear? Okay, yeah? Everyone clear? Okay, now we go to the solution already. Solution. So the first is to find the angle. So the angle for element 1 is 135. Do I need to explain how you get 135? So do you need me to explain why you get for element 1? Why the theta is 135?
90 plus 45 degree.
Again, remember what is your theta? Theta is anti-clockwise from where to where? You have to understand. From x to x prime. This is your theta. From x to x prime. Okay, so you refer to diagram, you need to add some of the, you need to sketch something on your diagram so that you can see the angle. So for element 1, theta is not 45, but is 90 plus 45 because it's measured from x to x prime. Anti-clockwise positive. Okay. Okay, Ashmal, can you explain theta for element 2? What is the theta for element 2?
180.
Correct. Okay, Sue. I don't want to ask Sue lah. Sue, I keep asking Sue so many times. Chia, what is theta 3? What is the element 3 angle?
270.
Correct. Okay, so I think everyone understand already, yeah? Okay. So the next is just build a table, calculate what is your cos, sine, cos square. Sorry? Brian, you try to say something, right?
I had a disconnection. I didn't hear what you said.
Okay. So do you understand the theta y is 135?
Yes, I understand that.
Okay. So you just calculate, use your calculator to calculate all this, sine theta, cos theta, and so on. Then you put inside, you substitute all the numbers. A is given, E is given, L is given. The rest is just your homework or just your calculator skill. Punch your calculator, put in the value. Again, when you after you write your answer, check diagonal direction, make sure positive. Check top and bottom, make sure they are aligned. The number is aligned. Okay, so sometimes the student, they accidentally drop the negative here. They will write this one positive. Most probably, they will write this one negative. Then wrong already. Okay, check your answer before you submit. So these are the area of mistakes. Then you just get the finalized answer. After you get this one, you reduce your answer to a more presentable. You can calculate the constant in front first. Means you can calculate this one first. Then you calculate the second one or the third one. Then you look at the constant. Then see what adjustment you need to do. Okay, important later when you combine all of them, this number beside the metric must be the same. Okay, the strategy we solve lah. Okay, so as you can see, I already start doing some modification on the equation here. All the 0.5 I already factor, and then I do something on the constant value. I get 1 in the matrix. Then I do the second one. Second one is 180. You calculate cos and sine, substitute accordingly. The length is 10 meter. And also you get 105, 10 square, and the cos and sine value inside the matrix. Then after that, you solve for the third one, 270. Oh, the 3 is missing here. Okay. Then cosine, and you calculate, you get the K3 equal to 20 and so on. So as you can see, you need to make adjustment on this one because the previous one is 105. Okay, so this one is 20. You need to make adjustment, or you need to change the first one or the second one to 20. You need to change this one to 20. You multiply inside there. You change this one, or you change the third one. Important is the constant value outside the metric must be the same so that you can park the number. If not, you're not able to park the number. Okay. So you apply boundary condition here. So if you write this one, U2, V2, U3, V3, U4, V4 equals 0. Here, you at least in test, at least you will score 3 marks. This one give you 1 mark, 1 mark, 1 mark. So this equation give you 3 marks in your answer. Okay, boundary condition, there will be one particular section ask you to write the boundary condition. This is your boundary condition. You look at the point, is there any displacement happening? This one mount to the wall, no displacement. Mount to the pin, no displacement. Mount to the pin, no displacement. However, there's a displacement at point 1. Okay. After that, you look at the F equal to KD. You write F equal to KD. After you combine all the matrix, you do it the displacement. You substitute a displacement inside here. We agree that we have 8, right? We have 8 displacement. So use your ruler to draw. Your K is a very big K. You have 8 number because you have 0.1, 0.2, 0.3, 0.4. So you have U1, V1, U2, V2, so on. U3, V3, U4, V4. Same with this one. So you have 8 times 8 matrix. It's quite a big metric. This metric alone will cost you 4 to 5 marks if you manage to find the K matrix. You manage to park the number correctly, you will score 4 to 5 marks for the matrix alone. Okay. Then after that, you use your pencil to close all the displacement. If the displacement is 0, you just close it. So you only left out one displacement, which is U1 and U2. So you only left out F1X, F1Y. You have the K here. So you just substitute F equal to KD. So F1X 0. I'm going to explain this one more time. Why this one you can see as 0. As you can see here. So you are having okay, let me see the diagram. Okay, this diagram. Yeah, okay, here you can see it. All right. Now, how can we write F1X equals 0? What mean by capital F? Capital F mean external force. You look at the diagram, you only have one external force. It is in Y direction. There's no X direction. Okay, there's no external force in X direction. So your F1X 0 here. So straight away you can write 0 for F1X here. So this one will score you 1 mark also when you write 0. Means that you understand what is happening to the system. And be careful on the negative sign. Here, F1Y equal to negative. Okay. And you do the calculation because for first element, you have your K and you have a D. This one you calculate from the equation. Okay, you calculate from the AE divided by L with your positive 1, negative 1, negative 1, positive 1, and so on. There's a calculation there just now. Yeah. Then times the cosine and so this. Okay. So this one you get from here. Okay. So this one U1. This one element 1. Element 1 is connecting U1, V1, U2, V2 because element 1 is connecting point 1 and point 2. So you know that your U2, V2, 0, right? Your point 2 cannot move. So you use your hand or use your pencil just to close third row and fourth row. You're only seeing this one. Okay. So you solve. Okay, you solve for your K of your matrix there. Okay, so you'll get, after that you solve for two linear equation. You'll get U1 equal to negative something, V1 equal to negative something. Right, so this one could happen in element 1. Okay. So U1 negative, it means it moved to this direction. U1 negative, it will move in this direction. This one when you refer to element 1. Okay, refer to X and Y direction. Yeah. Then you solve for the stress inside the bar. Recall the equation, stress equal to C prime D. Recall what is your C prime. C prime equal to EL times this whole thing. Substitute all the numbers. You calculate your EL minus 1, 1, and times the cosine matrix. You get the stress for element 1. Okay, you have your U1, V1, you have U2, V2. You just do mathematics calculation. You'll get stress inside element 1 will be 512 megapascal. When you get a positive, it means you have a tensile loading, meaning you're pulling at both ends. Okay, when you have positive stress, it means you are pulling at both ends. You have a tensile loading. Okay, you need to know how to explain now. When you get positive stress, it means you're having a tensile loading. You do the same, element 2. Substitute all the value. You get stress 2 equal to negative 36.2 megapascal negative. It means compression. When your stress is negative, you get a compression loading, means compression reaction. You compress element 2. Okay, so this is how you do it. Okay, so the question asks you to solve for bar element. Okay, the question asks you to solve for bar element. Okay, solve 2 bars. Okay, and if you look at the K, even though you don't need to solve, but if you look at the element 3, what is the loading of element 3? What do you think? There's external force here, 25 kilonewton on element 3. Mounted on the wall, there's a stress from top Does it a compression or tensile loading? Very straightforward, right? Let's see if you understand. Sue, are you able to tell the reaction of spring here? Does it experience compression or tensile loading, tensile reaction?
Compress.
Okay, good. So means you compress, huh? All right. Means that you understand. One more before we end. So another structure we call it reflective symmetry, meaning if you look at the screen here, it means that left and right will be the same. If you cut into half, you actually can mirror them side by side, even you cut, right? So in this scenario, for the first diagram example, you can cut the first truss into half and it does need to analyze half of it. Okay, and the same for the right hand side also, you see two triangular there. You only need to cut half here like this, and then you analyze. Let me see here. Okay, sorry. For the second one, you cannot. Second one. Yeah, second one you can cut because the force is the same. Right? You can cut half, then you can do analysis on one side of the structure. This is what will happen when you use software. We call it a symmetry analysis, where you only need to draw half of the object, then you will see the projection of the same results as you simulate the whole thing. Okay, just that something you need to be careful, especially for this one. If you split this one into half, be careful on the load that you use, because the load here is 2p. So when you simulate later or you do calculation, the force acting at 0.4 only is p, not 2p. When you simulate using reflective symmetry method approach. Okay, so you will see that if you try to find the answer, you can find that the displacement at 0.2, 0.3, and 0.4 will equal to this one. Okay, you can prove if you try to solve using the method that we learned for this chapter. It will be the same, only you can cut half. Be careful only on the loading. The loading you need to divide by half and not using the full loading, because you're only simulating the half of the object. Okay, so when after you find the displacement, all right, when you try to prove it whether it's equivalent or not, then you need to times 2 the p, right? You can see whether the structure is stable or not. Okay, now this slide is just to expose you there's one structure called reflective symmetry. So these are the example. Okay. All right, now with this I end the recording.